Welcome back to video 6 in our series on conceptual modeling featuring the ER diagram. Let's start this session off with a discussion of cardinality. The cardinality ratio for a binary relationship specifies the number of relationship instances that an entity can participate in. For example, in the works for binary relationship type, department employee is of cardinality 1 to many, meaning that each department can be related to any number of employees, but an employee can be related to only one department. This means that for this particular relationship works for, a particular department entity can be related to any number of employees. N indicates there is no maximum number. On the other hand, an employee can be related to a maximum of one department. The possible cardinality ratios of binary relationship types are 1 to 1, 1 to many, many to 1, and many to many. The participation constraint specifies whether the existence of an entity depends on being related to another entity via the relationship type. This constraint specifies the minimum number of relationship instances that each entity can participate in, and is sometimes called the minimum cardinality constraint. There are two types of participation constraints, total and partial. In a relationship between employee and department, total participation means that every entity in the total set of employee entities must be related to a department entity. Total participation is also called existence dependency. We do not expect every employee to manage a department, so the participation of employee in the relationship type that we'll call manages is partial, meaning that some or part of the set of employee entities are related to some entity via manages, but not necessarily all. In ER diagrams, total participation, or existence dependency, is displayed as a double line connecting the participating entity type to the relationship, whereas partial participation is represented by a single line. Relationship types can also have attributes similar to those of entity types. For example, to record the number of hours per week that an employee works on a particular project, we can include an attribute, hours, for the work zone relationship type. Another example is to include the date on which a manager started managing a department via an attribute called start date for the manages relationship type. Entity types that do not have key attributes of their own are called weak entity types. In contrast, regular entity types that do have a key attribute are called strong entity types. Entities belonging to a weak entity type are identified by being related to specific entities from another entity type in combination with one of their attribute values. We call this other entity type the identifying or owner entity type. We call the relationship type that relates a weak entity to its owner the identifying relationship of the weak entity type. A weak entity type always has a total participation constraint, existence dependency, with respect to its identifying relationship, because a weak entity type cannot be identified without an owner entity. However, not every existence dependency or total participation results in a weak entity type. For example, a driver's license entity cannot exist unless it's related to a person entity, even though it has its own key license number and is therefore not a weak entity. A weak entity type normally has a partial key, which is the attribute that can uniquely identify weak entities that are related to the same owner entity. In our example, if we assume that no two dependents of the same employee ever have the same first name, the attribute name of dependent is the partial key. Those of you who know about former heavyweight champion George Foreman's children's names, try not to think about that. George named all of his children George. In the worst case, a composite attribute of all of the weak entity's attributes will be the partial key. In ER diagrams, both the weak entity type and its identifying relationships are distinguished by surrounding their boxes and diamonds with double lines. The partial key is underlined with a dash or a dotted line. That's enough for this video. We started out talking about cardinality, and then we finished up with a discussion of weak entities. Let's make cardinality our mystery word. Go ahead and submit it, and then go out and check your knowledge on the material covered in this video. And when you're ready, come on back and we will proceed to video number 7 in the series on conceptual modeling, based on the book by El Masri and Navath, Fundamentals of Database Systems, 6th edition.